Welcome to all plus 2 students in Tamil Nadu for the refresher course 2025 conducted by Joy University, Tirunelveli. This is Raj Kumar from admission team, Joy University. Hope you are all busy in preparing your plus 2 exams and give some tips and tricks for the exam. Joy University has planned and refresher course for the subjects like mathematics, physics, chemistry and biology with top-notch faculties. Today your session will be mathematics, so which will help you to score high marks and get a remarkable success. Please utilize this opportunity. Once again, congrats all the plus 2 students for the exams. Now I invite Dr. Pallab Maiti sir from Joy University, who is going to handle this session. Please welcome sir. The stage is yours. Okay.
Thank you, sir. Okay. So today we will start a new topic. It's an application of integration. Although it's plenty of applications of integrations are there, but today we will discuss only area under a curve. It's a very important topic from the point of view of mathematics as well as physics. Sometimes we can use from chemistry as also, in economics also. Many perspective we can use that thing. So before going to start this topic, give some introduction. So why it is needed? Okay, so area of curve, the region bounded by some function and the x-axis, that is the main concept. And after that we will give some another applications, the volume of solid of the evolution. So why we want to learn these topics? It's essential for the solving real world problem. We have applications in physics, chemistry and some engineering perspective. Okay, also in understanding behavior of functions and the geometric interpretation. Because of area under curve, how the curve moves, how the curve actually, if we can define the area or how the curve actually under some geometrical concept, that thing can discuss from this topic. So the main formula for this formula is that area we can define a to b fx dx. Before going to start this topic, the main necessary concept is that the function fx must be a continuous function. Whenever we are discussing the area or we want to calculate area under certain curve, this thing must be this function must be a continuous function. Otherwise, this is very crucial thing. Otherwise, we cannot define the area under a curve. Otherwise, we cannot define. Suppose this is a curve, this is a function, fx is a function, and this is a continuous function. And we want to investigate the area from x equal to a to x equal to b. So how to compute? We want to compute that area. So that area can be find out by this integral a to b fx dx. And here this function, and mind it, this a and b both are finite. Both are finite. We cannot assume that a tends to infinity or b tends to infinity, or a tends to minus infinity or b tends to infinity. We cannot assume. We have to assume that a and b must be a finite quantity. Otherwise, we cannot compute. So for the plus 12 standard students, it is very essential that this function should be continuous, as well as this a and b must be finite. Then only we can compute. Okay. Suppose another example. So how to interpret that thing? Suppose this is a curve y equal to x square, and we have to compute the area under the x-axis and x equal to 0 and x equal to 2. Inside that curve, how to find out the area? Okay. So for this purpose, first we want to see the graph. This is very important thing, how to do the graph. So for this graph, we are using a very famous tool. It is Desmos. You can use. So here we are using y equal to x square, and x equal to 1, x that equal to 1. So inside that bounded zone, we have to find out the area. For this purpose, what we are doing, see, this is 0 to 2 x square dx. Here for this particular case, For this particular case, we know that my x square is a continuous function. X square is a continuous function, as well, actually it is a parabola. Okay, and here a, our formula is that a to b fx dx. This is my formula. So here a is 0 and b is 2 and f of x is x square. Okay, everything is given here. Now we have to find out the area inside the zone. Here x equal to 0, okay, and here x equal to 2, and we have to compute the area this shaded zone. So it is 0 to 2 x square dx. Now we have to solve the integration. If we do the integration x square dx, it is nothing but x cube by 3. Now just we substitute the value, means we put the upper limit minus lower limit. So it's coming in 8 cube by 3 minus 0. So it is, sorry, 2 cube by 3 minus 0. So it's coming 8 by 3. So that is the answer. So in that way, we have to solve the area under curve. One more thing, that the curve must be bounded. If it is not bounded, that time also we cannot compute the area. Suppose if I am giving one example, if I am saying that suppose I am saying the x square, I am writing x square, x is less than or equal to 1. Now you can see that, suppose this is x axis and this is y axis. Now we have to find out the area inside that curve. Okay, so that is x equal to 1 line and x is less than 1, so that zone. But you can see that it's an unbounded zone. So for unbounded zone, we cannot compute the area. So for this purpose, we should not assume that thing. Okay. Now another example is how to find out the area under the circle, that is x square plus y square equal to 1 using the integration. So actually in the class 7 or 8 standard students, you know that how to find out the area of circle, means x square plus y square equal to 1. This is a circle having radius at 0, 1 and origin means 0, means center at 0, 0. Okay. So that is everything, center at the origin and radius is r. Okay. And we know that how to compute the circular area. So area is pi r square. Here r is 1, so the area should be pi. Now by integration, this result is coming or not, we should validate. Okay. So how to do that thing? So before that, this is my circle. This is my circle. So So this is my circle, and if I draw this circle, now this point is, if we draw the line, this point is x equal to 1, this point is x equal to minus 1. Okay. Now you can see that this fourth zone, this one part, this is second part, this is third part, and this is fourth part. Both the fourth part having equal area, because this circle all the time it is symmetric about x axis as well as it is symmetric about the y axis. So these all the four portions are same. Now what we are doing, first we compute the area on that shaded zone, only that shaded zone. After that we multiply with 4, because of since 1, 2, 3, 4 both are same. So we no need to compute the entire area. First we find out the area by the first quadrant, means x greater than or equal to 0 and y greater than or equal to 0 together with x square plus y square equal to 1. Inside the zone, first we find out the area, after that we multiply with 4. So we will get the entire area. So how will do for this purpose? So that is my area, y equal to root over, because of x square plus y square equal to 1. So we can write that y equal to 1 minus, since x square plus y square equal to 1, from here I can write that y square equal to 1 minus x, that implies that y is equal to root over of 1 minus x square. We are assuming only positive sign, because we are considering only upper wing, not the lower wing. Okay. Now in the first quadrant, it is 0 to 1, because the circular disc, circle this is minus 1 to 1. So our limit is from 0 to 1. Here 0, lower limit is 0 and upper limit is 1. Now I want to compute entire this zone. So it is from 0 to 1 root over of 1 minus x square dx. After our procedure is that we multiply with 4 times. So this area into 4 times we get entire area. Okay. So that was a simply integration 0 to 1 root over of 1 minus x square dx. How to solve this integration? We substitute by a x by sine theta. We taking x equal to sine theta. It's a method of substitution. By this way I can solve the area. Okay. Also we can solve, we can directly, if you know the formula, we can directly use the formula. The formula is that integration root over of a square minus x square dx. That formula is a square by 2 root over of, the formula, 1 minute. The formula root over of x square minus x square dx, the formula is x into root over of x square minus x square by 2 plus a square by 2 sine inverse x by a. By that formula also we can solve that problem. Here a is 1. Okay. So from here we can solve this using this formula also you can solve that problem. Otherwise by substitution method, simply taking x equal to sine theta, then our dx is coming cos theta d theta, because with respect to theta which we differentiate, it will come cos theta, derivative of sine theta is cos theta. Now just substitutes, so 1 minus sine square theta, that is x value is sine theta, and dx value that is cos theta d theta. Just we simply put here cos theta d theta. So it is 1 minus sine square theta equal to cos theta, because of sine square theta plus cos square theta equal to 1. So it is cos theta, so cos theta into cos theta cos square theta. Now using the formula of cos 2 theta, we are writing that cos square theta equal to 1 plus cos 2 theta by 2 d theta. Now this is simply we half outside, so it is theta plus sine 2 theta by 2. Now we back substitute, then this is my result. So if my x is sine theta, so theta is sine inverse x. Okay, so that thing we are substituting back. Now this is my result. Now we have to substitute the limit, upper limit minus lower limit. So if you put the upper limit, it is sine inverse 1 plus x into 1 minus x square, that is 1 by 2, so it's 1 minus 1 coming 0, you say 0 minus lower limit sine inverse 0, that is actually 0, and 0 into something is 0. So it is half of sine inverse 1, and sine inverse 1 value is pi by 2. Actually we are considering only the first quadrant, that's why its sine inverse 1 is pi by 2. So entire value is pi by 4. Now you get that result that so far you compute only that portion we have computed. So that is my coming pi by 4. So 4 portion are there, so we have to multiply with 4. So it will coming pi by 4 times pi by 4, that is equal to pi. Okay. So far we have know that the area of the circle is pi r square. For this particular case r equal to 1, so area should be pi. Now we can validate by our integration formula that it is coming that area is actually pi. Okay. Now another example of the application of this integration, how to compute the area of a ellipse. You know that how to compute the ellipse, how to draw the ellipse. So the ellipse is this is x-axis, this is y-axis, and this is a, this is minus a, this is b, and this is minus b. Okay, this is a comma 0, and this is minus a comma 0. So we have to find out the area enclosed by this curve. This is my curve, this is my ellipse, x square plus a square by y square plus b square by b square equal to 1. For this curve, how to compute the area by integration method. Okay. So you know that this is a major axis and what is minor axis. Your A is major axis and B is minor axis and center at origin. Okay. Now similar thing here also we can use same method, seems like circle, because of what our main plan is to find out this is a ellipse. So first we compute the zone in the first quadrant. First we find out the area inside the first quadrant, that is x, that is x dash, that is y dash. Inside that zone we have to first find out the area. After that, since all that are symmetric, we have to multiply by 4. They will get our required result. Okay, but you can see that, so my case is x square y square by b square, and here x square by a square, that equal to 1. So simplifying we get that, if you simplify it will come b equal to y equal to b times root over of x square minus x square by a square. Okay, so we are taking only positive value because of we are considering the upper portion. That's why we are considering only positive value. We are not bothered about the lower portion. After that, we have to multiply with 4. So now by same technique we have to compute or to find out the area from 0 to a, because of in that case in that case this is ellipse. So in that case this is my 0 and this is my a comma 0. So we have to compute. So this is my lower limit and this is my upper limit. So this is 0 to a. Okay, so here 0, here a. 0 to a, we have to compute that portion area of that first quadrant inside the first quadrant. So b into root over of 1 minus x square by a square into dx. Now the simply substitution method we can use, otherwise we can directly use the formula for the integration. If you directly apply the formula of integration also, you can find out that result. It will come pi ab divided by 4, that will be the result. Okay, otherwise you can simply substitute by x by a sin theta. If you substitute the value of x by a sin theta, that time also we will get the same result, pi ab by 4. Now we are getting the area only the first quadrant, only the curve under first quadrant, inside the first quadrant. But we have to compute entire 4 portion. This is the first portion, this is second portion, that is third, and that is fourth portion. So we have to simply multiply with 4, because of all the 4 portions are symmetric. So we have to multiply by 4. So now we are getting that area is 4 times area inside first quadrant. So it will come 4 into pi ab by 4. It will come pi ab. Okay, so this is your result. This is the result for the area inside the elliptic curve. Now you can see that if my a equal to b, from here also you can see that the area of ellipse is pi ab. Now if my a and b are both are same, that time pi ab is converted to pi a square. That is the area of a circle. So ellipse is actually generalized version of circle. Means if a and b are both are same, that time any ellipse can be converted to a circle. Okay. So far we have discussed the area under only one curve. Now if I have given 2 curves are there, okay, suppose this is my x-axis, this is one curve, this is my fx, this is one curve, and this is another curve gx. Both the 2 curves are there, fx and gx. Now how to compute the area inside some portion. Suppose I want to find out x equal to a to x equal to b. So how to find out that portion is the thing. Okay. So here also same thing, fx and gx, the necessary condition is that the fx and gx must be a continuous function, otherwise we cannot compute the area inside that curve, the inside that from A to B. Okay. So another thing is that how to compute that thing, the formula is that it is should be A to B fx minus gx into dx. That is the formula for computing the area under two curves fx and gx, which is bounded by A and B. Okay. But one more thing, this is very important, is that here f of x is all the time greater than or equal to g of x for all x belongs to a comma b. If my a comma b, inside that interval a comma b, fx and gx, what is the relation? Fx is all the time greater than or equal to gx, that time we have to use that formula. If gx is greater than f of x for all x belongs to ab, that time our formula is changed to gx minus fx. Means whichever is larger, that should be here and smaller portion should be here. So that is the formula for computing area under two curves. Okay. So that is the formula. Suppose we want to find out the area y is equal to x square and y is equal to x, and which is from x equal to 0 to x equal to 1. Now we want to see how the curves looks like. Okay. For this purpose we have to use, okay, first we will use y equal to x square, and next line is that equal to x equal to 1, x equal to y equal to x inside zone. Now we have two curves, one is y equal to x square, that is the green line, another is y equal to x, that is purple color line. So inside that zone we have to find out, that means that portion we have to compute the area. So here we are writing here x minus x square. Why we are writing x minus x square? Because of, if you see the curve, then you can see that is my y equal to x square, and that line is y equal to x. So which line is above? So here fx, this is y equal to x, and below this is y equal to x square. So you can see that my f of x, that is your x, and g of x, that is x square, and which line is above? My that line y equal to x line is above. So that's why we are writing x minus x square. Now we have to compute the area from 0 to 1, because it is given from 0 to 1, and intersection point is 1 comma 1 here. So from 0 to 1, that is inside that portion we have to compute the area. So it is 0 to 1 x minus x square dx. Now simply simplify the integration value. So x integration is x square by 2 and x square integration is x cube by 3. Now we are putting upper limit and lower limit. Here upper limit is 1 and lower limit is 0. Once you put the upper limit and lower limit, we will get 1 by 6. So here the necessary condition is that f of x is greater than or equal to g of x for all x belongs to here 0 comma 1, and in that particular case my f of x is x and g of x is x square. Also you can see that thing from my graph also, my f of y equal to x line above line and below gx, that is x square. So we can write fx minus gx, that is x minus x square. So from here also you can see the graph. Now another area curve. We have to find out the area between the curve y equal to x square and y equal to 2x minus x square. Although both are parabola, so now we can see how these two curves looks like in. Okay. So one is x square, it is fine. Now you have to write down, that is 2x minus x square. Now you can see that the green color line, that is x square, and the purple color line is 2x minus x square. Okay. Now we have to find out the area inside that curve, that is from here to here. Now first we have to find out the intersection point. Then only you can find out the area enclosed by these two curves. One is y equal to x square, another is y equal to 2x minus x square. So first we have to find out the intersection point. For this purpose, what we have to do, x square equal to 2x minus x square. Because of for finding the intersection point, we have to equate these two equations. So y equal to x square and y equal to 2x minus x square. So if I equal both the values, x square equal to 2x minus x square. Now we simply simplify that thing. We are getting the two intersection point. One is x equal to 0 and another is x equal to 1. Also from the graph, we can see that here this 2 point, this is the 2 point. You can see that this is x equal to 1 line, so it's an intersection 1 comma 1 point, and here 0 comma 0. So both the points are actually intersection point of these two curve. One is green color curve, another is your purple color curve. So both are both the curve meet at 0 and 1. Now using the formula from the integration, it is 0 to 1. Here also same thing, which curve is above and which curve is below, that curve we have to understand. So from the graph we can see that curve, this purple color curve, this is above, that is 2x minus x square, and below it is x square. So it is 2x minus x square minus x square, because of this is my this is f of x and this is g of x, and here also you can see that f of x is greater than equal to g of x. Which curve is above and which curve below, that thing first we have to understand. So for solving such type of problem, we have to first draw the graph, otherwise we cannot solve. So before start any problem like that area under a curve, first we have to draw both the curves, otherwise we cannot compute the area. Okay. Although here we can use Desmos, but we have to knowledge how to draw the curve. So this is actually parabola, this is another parabola. Okay. So by using that that sense of parabola, we have to find out the curve, and where it is meet two curve, that is meeting point is 0 and 1. Once we get the meeting point 0 and 1, from there to there we can, this is my upper limit and this is the lower limit. Lower limit is 0 and upper limit is 1. So 0 to 1 we have to compute the area enclosed by this two curve, and if you compute it will come 1 by 3. So the area inside that y equal to x square and y equal to 2x minus x square, it is coming 1/3. This by simple integration we are getting the result. Okay. This is the curve actually. Now another problem is that how to find out the area y equal to sin x, another is y equal to cos x. Inside that zone x equal to 0 to x equal to pi by 2. Okay. Now you can see first our main aim is to to draw the curve, otherwise we cannot solve. First we have to understand what is sin x curve looks like. Our sin x curves actually sin x, and here it is cos x I am writing. Our red color curve is actually cos x curve and black color curve is sin x curve, and we have to find out the area, that portion from 0 to pi by 2. Pi by 2 means where actually that curve, that is your cos x equal to takes the value 0, because at cos pi by 2 value is 0. From that line, that point to that point we have to find out. You can see that point to that point we have to find out the area inside that thing. Okay. So how to compute? So there are two zones there. One zone is that portion, another zone is that portion. So what we are doing, first we understand the curve. So this is my curve. Okay. So that is x equal to 0 line, x equal to 0 line, and this is x equal to pi by 2 line. We have to find out the area inside z zone and inside that zone. We have to compute. See, for this purpose, first we have to find out the intersection point where sin x and cos x meets. Okay. So if we equate it, then we are getting that intersection point is sin x equal to cos x, it will come x equal to pi by 4. That is, at x equal to pi by 4, both the curve value is same value. And if I observe that value actually is pi by 4 value. That value is pi by 4, means here x equal to pi by 4. So we have to find out that zone and that zone, and here it is pi by 2. Okay. So how to compute? It's very simple thing, very simple. Listen, 0 to pi by 4, and another is my pi by 4 to pi by 2. Now we have to understand in that curve which curve is above curve and which curve is below curve, and here which curve is above and which curve is below. Okay. Now this is red line curve, that is actually cos x curve, and this is blue line curve, this is sin x curve. Okay. Now you can see that 0 to pi by 4, inside that zone which curve is above? This cos x curve is above. So here it is cos x minus sin x dx. But inside that zone, pi by 4 to pi by 2, inside that zone my blue curve is above and red curve is below. So here sin x minus cos x dx. Now we have to simply solve the integration. Simply use the integration formula, we will get that value. Here see 0 to pi by 4 cos x minus sin x, and pi by 4 to pi by 2 sin x minus cos x dx. Now if I apply the integration formula, then we will get that value sin x, and integration of cos x is sin x, and sin x integration is cos x. Similarly, sin x integration cos x minus sin x, so minus cos x, and cos x integration is sin x. Now we substitute the upper limit minus lower limit, we will get that 2 root 2 minus 2. So that is the ultimate answer. So the area and the curve between sin x cos x from 0 to pi by 2, the value is 2 root 2 minus 2. Now another thing is to find out the area between the curves y equal to x cube and y equal to x. So similar approach, first we have to draw the two curves y equal to x cube, another is y equal to x. After that we have to find out which curve is above and which curve is below. Then above curve minus below curve, we have to do it. Okay. So just we see how the curve looks like. Another curve is y equal to x, and another curve is my x cube. These two curves are there. Now you can see that this is your green color curve is y equal to x cube, and blue color curve is y equal to x. Now we have to find out the area bounded by these two curves. Now because this is one wing and this is another wing, so we have to find out that zone and that zone. So for this purpose, first we have to find out what is the intersection point where these two curves actually meet. Now from the graph we can see that here minus 1, that is minus 1 point, minus 1 minus 1, at that point this curve meets. Also at minus 1 comma 1 you can see it's 1 comma 1 the curve meets, and 0 comma 0. So these 3 points, minus 1 comma 1, 0 comma 0, and 1 comma 1, at these 3 points these two curve actually meets. So now we have to find out that portion in plus that portion. So how we will approach? So first we have to find out the intersection point by mathematically. Just now we have solved C in the graph, but how to solve by mathematically for x cube and y equal to x, where it meets. So equate these two equation. How to solve? First we have to equate that y equal to x cube and y equal to x. So how to find out intersection point? We equate two equations, x cube equal to x. Now if I get in the x into x square minus 1, if I take the common, it will come x into x square minus 1. So product of two element, x into something, since it's a real number, so either x equal to 0 or x, because x into x minus 1 equal to 0, that implies that either x equal to 0 or x square minus 1 equal to 0. Okay. So x equal to 0 we are getting, but from x square equal to 1 we are getting x square equal to 1, so x equal to plus minus 1. So from here also you can find out the intersection points are 0, plus 1 and minus 1. So there are three intersection points. Okay. Now what we are doing here, my curve is x cube minus x and another is x minus x cube dx and here dx. So first we have to identify where this thing hold and where this thing hold. Now we have to see the graph. If you see the graph, you can see inside that portion, means 0 to 1, inside that zone, 0 to 1, inside that zone, my blue line, that is y equal to x line, this dominates the y equal to x cube line. So 0 to 1, inside that zone, x is larger and x cube is smaller. So x is larger and x cube is smaller, so that is the thing. And another way, x cube minus x, inside that zone also you can see that minus 1 to 1 0, inside that zone our green line, that is our x cube line, actually dominate y equal to x line. Inside that zone x cube value is larger and y equal to x value is smaller. So here it is coming minus 1 to 0. Now this is one integration and this is another integration. Now we have to simplify this equation. After that we have to add, because two portions are there. Now if I add it, see, you can see the minus 1 to 0, x cube minus x, and here 0 to 1, x minus x cube dx. Now if I simply simplify this integration, it will come x to the power 4 by 4, this is the integration of x cube, and x integration is x square by 2, and here x is x square by 2 and x cube integration is x to the power 4 by 4. Now we are taking the value from upper limit and lower limit. So upper limit minus lower limit, if you are doing, we are getting the result that 1 by 4 plus 1 by 4, that equal to half. So the area inside the curve y equal to x cube and y equal to x is nothing but half. So for solving such type of problem, we have to understand three things. First, we have to understand what the curve looks like. First, we have to draw both the curves. After that, we have to find out where these two curves intersect. Once we find out the intersection point, it is very easy to find out the area, means where from where to where we have to integrate, because we have to know what the integration levels, means upper limit and lower limit. For this purpose, we have to find out the intersection points. Okay, for this, like for this problem, minus 1, 0, 1, these are intersection point. Similarly, for others problems also, there are three steps are there. First, we have to draw the curve. After that, we have to find out the intersection point, and third is compute the area. In that way, you can compute the entire, you can solve the entire question or entire problem. Okay, so now we will go to next problem, similar type of problem. Y equal to e to the power x, another is y equal to e to the power minus x. Two curves are there, y equal to e to the power x, another curve is y equal to e to the power minus x, and from y equal to 0 to x equal to 1. So first we have to understand how the curves look like, what the curve e to the power x looks like and e to the power minus x looks like. Okay, so if you know that this is my x axis and this is my y axis. Okay, now what is the value of e to the power x? Y equal to e to the power x takes the value at 1 when x equal to 0, that thing we know, and e to the power x value we know at x tends to infinity, e to the power goes to infinity, and if x tends to minus infinity it goes to 0. So e to the power x curve actually looks like that. This is my e to the power x curve. Okay, that is my e to the power x curve. Similarly, e to the power minus e to the power minus x at x equal to 0, at x equal to 0 it will come y equal to 1. Okay, and if you put x equal to infinity, means if x approaches to infinity, the y approaches to 0. Okay, but never actually intersect. So these are two curves. Red color curve is y equal to e to the power minus x, and white color curve is y equal to e to the power x. Now we have to find out the area from x equal to 0, that is y axis, that is x equal to 0, that is the intersection point. Okay, that is 0 comma 1. Here these two curves actually meet to x equal to 1. If I assume here x equal to 1, okay, so inside that zone we have to find out the value. Inside that zone we have to find out. So how to compute? See here our e to the power x minus e to the power minus x. Okay, which curve is above curve? This e to the power x is above, and this is below. This is e to the power minus x curve. So e to the power x minus e to the minus x into dx, and 0 to 1. Now if you simply integration, we will come that e to the power x plus e to the minus x 0 to 1, it will come e plus 1 by e minus 2. In that way we can solve the in area under the curve e to the power x and e to the power minus x from 0 to 1. Now another problem we want to solve it, y equal to log x, where y equal to 0 and x equal to 1 to e. There are three portions. First we have to find out what is the bound, means what are the limits for this particular problem. We know that what is the log x graph. Okay, just you can see in the also Google, you can see how log x graph looks like. This is a very nice applic tools. It's called Desmos. Here also can anyone can, if you write down any curve, they simply give your a picture of that curve. So I am writing what is the log x or ln x. Log function, then x. Now you can see this is my log x graph. We know that, everyone know that log x is a function at log 1 equal to 0. Okay, so this is a log x curve. Now we have to find out the area from 1 to e. Now I have just write down what is x equal to e line. We have to just write down what is the value of x equal to e. Simply can write down okay, x that equal to e. Now you can see that we have to find out the area enclosed by this curve 1 to e inside that zone. Inside that zone we have to find out. So for this purpose we have to find out what is the intersection point. Okay, so that is my intersection point, and here this is one intersection point, and here one intersection point. So this is x equal to e value. E value is 2.718. Actually it is an irrational number. It is approximately 2.718. So we have to compute the area from 1 to e. Now how we will solve? We will proceed. So it is my curve. Here it is x equal to 1 line. That is x equal to 1 line. That is x equal to 1 line, and it is x equal to e line. And we have to compute that portion. So it's a 1 to e, lower limit is 1, upper limit is e, and inside that bounded zone we have to compute. So 1 to e log x dx. Now we have to solve this integration log x. Log x integration can be solved by how to solve log x integration. This is log x or ln x dx. This is a first function, so simply log x into dx minus, you know that derivative of log x into integration dx into dx. So that is the formula for computing the log x. So it is log x into integration is x minus derivative of log x is 1 by x, and integration of x is into x and dx. So if you simplify, it will come x log x minus, it is simply dx. So it is x log x minus x. If we take the common x, so it will come log x minus 1. In that way, you can compute the integration of log x dx. Now, using that result, here we directly write down that thing. It is x log x minus x, and upper limit is e and lower limit is 1. Now, we simply put down that thing. So, e into log e value is 1, okay, e into 1 minus e, and log 1 value is 0. So, it is 0 minus 1. So, it means simply all are limited. So, it is entire value comes to 1. So, entire value comes to 1. That is the result. Means the curve under y equal to log x and y equal to 0 from x equal to 1 to x equal to e. If we compute, the value is coming 1. Now, this is a very interesting problem and very useful problem, and maximum times such type of problem are asked in the question paper. The question says that how to find out or what is the area. So, this is a very important question, how to find out the area between two curves. Here are two parabolas is there, y equal to x square and x equal to y square, and this is very, very important questions. Every year means in JAM also, not only it's like your JEE main also, direct one question coming, what is the area enclosed by these two curves y equal to x square and x equal to y square. So, how to find out the area? Okay. So, actually the modified question is that y equal to ax square and x equal to by square. That is actually general question, but for this particular case I am assuming here a equal to 1 and b equal to 1. Now, how to find out the area enclosed by this curve? So, same thing, first we have to understand the curve, after that we have to find out the intersection point, after that we have to compute the area enclosed by these two curves. Okay. So, we know that what is the value of x square, that is the x square curve, that is x square curve. Another curve is that y square equal to x. I can see that is my curve. This is my curve. One curve is y equal to x square, another is y square is equal to x or x equal to y square. So, first you have to find out where these two curves intersect. Now, from the graph you can see that is 1 comma 1. So, from actually 1 comma at the point 1 comma 1, these both the curve actually intersect. Same thing at 0 comma 0, these two curves intersect. Okay. So, from here we can understand that from 0 to 1 we have to integrate. Also, here the blue line curve, that is y square equal to x, that curve is above, and x square, that curve is below. So, y square equal to x, that curve actually dominate that x square equal to y. Okay, that curve they dominate. So, we have to do the integration from that line minus that line, and integration should be 0 to 1. Now, see how we are doing. Okay. So, first we are find out the area. First we have to find out where that intersect actually. If we put a find out intersect, it is coming 1 and 0 0. Okay, the solution is not so easy. In the graph we can see, by easily you can see it is 1 comma 1, but here it is not so easy. So y equal to x square and x equal to y square. Now simply substitute value. So y is coming y to the power 4. So y is y to the power 4, so y is y cube minus 1. Since y is a real number, because we know that y cube is equal to 1, that equal to 1, that gives the value 1 omega square, but we should not consider the remaining two value because this is a complex root. These are complex root. We should consider only one value because of x and y both are real. That's why you have to consider only one value. Now, if you're getting y equal to 1, then simply put here, so you're getting x equal to 1. Okay, and if you're getting x equal to 0, y equal to 0, then you put y equal to 0, then we are getting x equal to 0. So our intersection points are coming 0, 0 and 1, 1. From the graph also you can see the intersection points. Also by manually we can calculate where these two curves actually meet. The value was 0, 0 and 1, 1. Now we have to find out what is the area inside that two curve. Now you can see which curve is above portion and which curve is lower portion. Now from the graph also you can see that this is one curve and this is another curve. Okay, and this curve is y is equal to x square and this curve is y square equal to x. So here y is root over of x and here is x square. So it is root over of x minus x square dx. Okay, so by that way we can calculate. See, that is y equal to x square and x equal to root over of x equal to root y square. And now we simply simplify that value 0 to 1 root over of x minus x square dx. Now it is x to the power half dx. So by the formula x to the power n, we know that the formula for the integration is integration x to the power n dx, that is x to the power n plus 1 divided by n plus 1, provided that n is greater than or equal to 0. That time only we can apply the formula, otherwise we cannot apply the formula. Here also you can see x to the power half, so half is greater than or equal to 0, so you can apply x to the power n dx. So it is x to the power half plus 1 divided by half plus 1. So x to the power 3 by 2 divided by 3 by 2. So okay, so it is coming 2 by 3 into x to the power 3 by 2. Okay, now we are putting lower limit and upper limit, so it's come 2 by 3. Similar thing for that function x square, if we integrate by using that for the result, here your n value is 2, so it is coming x cube by 3. Okay, now simply put the value at 1 and 0, it will come 1/3. So 2/3 minus 1/3, so the value is, ultimate value is 1/3. So this is very important result, is that what is the area between the two curve. This is the result, that the area between y equal to x square and x equal to y square, the area is 1/3. You have to remember the result, because in some competitive exam this question directly come. Find out the what is the area enclosed by the curves x equal to y square and y equal to x square. So that time you cannot solve all the thing, you have to write down directly, click the thing, also 1/3. Okay. Now find out the area bounded by the curve. One is x square plus y square is 16, another is x square equal to 6x. This is a circle and this is a parabola. So how to do it? Okay, first we see how the curve actually looks like. One is x square plus another is x square plus y square equal to 16. I think so. 16. So x square plus y square, that equal to 16. What happened? and another is y square equal to 6x. Y square that equal to 6 times x. Okay. Okay. Now we have to find out the area. Okay, 1 minute. That bounded curve means that portion. That portion. That is one 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 portion. And these 4 points are there. So the curve is bounded by these 4 points. One is 2, 3.44641. Here 2, minus 3.4 and 0, 0, and this point is 4, 0. So you have to find out the area bounded by this curve, that portion. That portion you have to find out. So how to find out that thing? Okay. Okay, so it's a center at 0, 4, center at origin at radius is 4. Okay, now first we have to find out where these points are actually intersect. That point actually intersect 2, 2 root 3, another is 2, minus 2 root 3. At these 2 points actually the curve intersects. So how to find out? First we have to find out the intersection point. This is very crucial or important thing. Okay, so this is my y square equal to 6x. Now you see simply my y square equal to 6x. Y square equal to 6x. So we have to substitute that value in that equation. Okay. So x square plus y square equal to 16. Now we have to simply substitute that value y square. So it is x square plus 6x that equal to 16. Okay. Now we have to apply Sridharacharya formula. That is x square plus 6x minus 16 that equal to 0. That is the equation. From here we have to find out the value of x. That is the Sridharacharya formula says that, you know the Sridharacharya formula, ax square plus bx plus c equal to 0. Then the root of the equation you can directly find out by the formula is x equal to minus b plus minus root over of b square minus 4ac by 2a by 2 times a. Okay, and in that particular case my equation is x square plus 6x minus 16 equal to 0. So my x a equal to 1, b equal to 6 and c equal to minus 16. Okay, now we have to just simply simplify that value. So my x is coming minus b means minus 6 plus minus root over of b square means 36, 6 square minus 4 times a into c, that is 4 times a means 1 here into c, that is 16 by 2 times a is 1. Okay. Now if I simply simplify that thing, it will come minus 6 plus minus root over of 36 plus 64 divided by 2. Okay. So it will come 100, 36 plus 64, it will come 100, and root over of 100 is coming 10. So it will come, it is minus 6 plus minus 10 by 2. That is, if we once you take plus sign, another time you take minus sign. If you take the plus sign, it will come minus 8, and if you take a plus sign, that is 2. Okay. But we should not consider minus 8. Now why we should not consider minus 8? That is a very important thing, because see x is coming minus 8 and x equal to 2. We should not consider x equal to minus 8, because of if you consider x equal to minus 8, then your y square is coming 6 into minus 8, that is minus 48. So y square is equal to minus 48. It is not at all possible. That means y square, something square is coming negative, it is not possible because of here x and y both are real number. Okay, y square equal to minus, it means 48 means y is coming iota, means a complex number is coming. Okay, root over minus 1 is iota, so it's complex number, so it is not at all possible. So you have to consider only x equal to 2. Once you consider x equal to 2, then your y square is coming 12. Okay, so y is plus minus 2 root 3. So the intersection points are 2 comma 2 root 3, another is 2 comma minus 2 root 3. So these two are intersection points. Now we have to compute the area enclosed by that thing. So how to compute? One is 0 to 2, another is 2 to 4. Okay, so if you see the curves, then you can see how we'll do. From 0 to 2, I am taking one line. From 0 to 2, another is 2 to 4. These two curves are there. Okay, so how to, because two curves are area may be different, not maybe, not maybe, certainly it is different. So we have to find out the area. Okay, so 0 to 2 and 2 to 4. Why I am doing 2 times? Because of, you can see it is symmetric, that above the curve, above the x axis, that portion and that portion, both the portion are symmetric around the x axis. That's why once I find out that portion, then immediately multiply with 2, I am getting the entire portion, because that portion are same. So we no need to compute the entire zone, only simply compute that above portion, above the x axis we are computing. After that we are multiplying with 2, because it is symmetric about that x axis, that portion and that portion are same. Okay, so simply we are doing 0 to 2 root over of 6x dx. Okay, and 2 to 4 16 minus x square dx. Why we are doing same thing like that way? This is actually tricky problem. You can see that is my circle and this is my parabola. Okay, okay, for the timing we assume that portion all are same. Okay, that is my 2 and that is my 4. First we have to find out that zone, after that we have to find out that green zone, and the green zone can be calculated by that value, and the red portion can be calculated by that value. Okay, that is the thing. Here root over of 6x, because we are considering the upper wing, so that is root over of 6x from 0 to 2, that is the value 0 to 2. Therefore 2, we have to consider that zone. After that 2 to 4, inside that zone 2 to 4, here 2, here 4, inside the zone root over of 16 minus x square, because of the curve is actually x square. Your circle is x square plus y square is equal to 16. So my y square is coming 16 minus x square. So y is root over of 16 minus x square, because we are taking the only above portion, means first quadrant. We have to consider the curve in the first quadrant. Okay, so that portion we are considering. Okay, from 2 to 4, 2 to 4 we are considering. Now we are doing simply integration we are doing. Okay, here it is very easy to compute, because x to 3 by 2, but for this particular case we have to use the same formula. The formula again I am writing the formula. The formula is root over of a square minus x square dx, that is x by 2 root over of x square minus a square plus a square by 2 sine inverse x by a. Okay, that is the result. Now here this particular case my a is 16, that is my a square is 16, so a is 4. So that's why I am writing here a square by a by 4, that is x by a, that is x by 4, and it is x square 16 minus x square. Okay, now on my lower limit to upper limit 2 to 4. Now simply if I put the limits, then we are getting that value. Just you can see how we are computing. So if I computing, it will coming 4 root 3 by 3 plus 16 pi by 3. That is the thing. Okay, this is actually some tedious calculation is there, you can do it. Okay, so if you compute, it will come 4 root 3 by 3 plus 16 pi by 3. So that is actually the answer. Okay, so that means if we uh, uh, the area enclosed by x square plus y square equal to 16 and y square equal to 6x, the answer is coming 4 root 3 by 3. That is the area answer, 4 root 3 by 3 plus 16 pi by 3. So it is a one kind of difficult problem, so you can do it. Okay. Now another problem, it's very easy problem. Find out the area region bounded by this y square equal to x and the straight line y equal to x minus 2. Okay, so first we have to write down, first we have to find down y square equal to x. Okay, so draw the curve. This is my x and this is my y. So y square is equal to x. Okay, and next line is that y equal to x minus 2. Okay, so y square x minus 2 seems like that line. Okay, where it intersect the x-axis and where it intersect the curve. How to compute that thing? Okay, so how to do? First, how to compute? We have to consider where it intersect at x-axis. So if you see that if you put x equal to 0, then your y equal to coming minus 2. Okay. Okay. Another is you have to find out that value. Okay. So how to find out that value? So simply equate these two equations. One is y square equal to x and one is x minus 2. So your x minus 2 whole square equal to x. If you simplify, that is x square plus 4 minus 2 4x that equal to x. So your x square minus 5x plus 4 equal to 0. So your x is coming, if you just simply middle term it, x minus 1 that equal to 0. So x equal to 1 comma 4. At these 2 points it intersects. Okay. Now see the curve where it is intersect. Okay, at x equal to 4 and x equal to 1, at these 2 points actually these two curve meets. Okay, now when we are assuming x equal to 4, that time my y is coming 2, and when I assuming x equal to 1, that time my y equal to minus 1. So the intersection points are 4 comma 2 and 1 comma minus 1. So these are 2 points where these two curves are actually intersect. Now we have to find out the area inside that curve. Okay, so now if I draw the curve, this is my curve. One curve is y, that is y equal to, here it is y equal to x minus 2, and here it is y square equal to x. So we have to compute that zone. That zone we have to compute. That entire portion we have to find out. Okay, for this purpose, what we are doing, with the above portion, it is minus 1 to 2. Okay, from minus 1 to 2. That time what we are doing, we are not doing the integration with respect to x-axis. Now we are doing with respect to y variable. That time we have changed. So here y. So here y plus 2 to y square. Now see the curve. From here to here, y plus 2 to, because your x is coming, my x is equal y equal to x minus 2. So x is coming y plus 2, and y square equal to x. So x is y square. Okay. From now, from here to here, minus 1, you can see this is minus 1 line and this is 2 line. Okay. Now inside that zone we are doing that thing from here to here, inside that zone. So how to compute? That is minus 1 to 2 y plus, this is y plus 2 minus y square dx. Sorry, you have to write dy, okay, right, dy, okay, how to compute. So how to compute that thing that is given, we are doing y plus 2 minus y square into dy. Now simply that doing the integration will come, y integration is y square by 2, 2 is constant term 2y, and another is y cube by 3, this is minus 1 to 2. Now simply to simplify that value, it's coming 10 by 3, okay. Okay, now in that way you can simplify that value. Now this is a very easy problem, okay, very easy problem, that 2x minus y plus 1 equal to 0, y equal to minus 1 and y equal to 3 and y axis. This is zone bounded by this four straight line. The four straight lines are there. One is 2x minus 1 plus 1 equal to 0, another is that line, the four lines are there. Now we have to compute the zone, compute the area bounded by these four lines. How to compute? So first see the curve, okay. Now see, that is my y equal to 2x minus 1, that is y equal to 1 minus 1, and that is y equal to 3, okay. Now we have to find out the zone. How to compute? Now you can see that this portion and this portion, these both the portions are actually same portion. Why it is same? Just to see, this is line, this is one line, and this is another line, and one curve is intersect, okay. Now you can see that these two actually same angle. Now this, since these two lines are parallel, so this angle and this angle are same. Now from here we can compute that area, that length and that length, these two lengths are same. So these two angles are, these two triangles are similar angle, these two triangles are actually similar. So once I identify the area of this angle, this triangle, then no need to calculate the lower portion. First we have to find out the area enclosed by that portion, that curves. After that we have to multiply, because that area and that area, both the area are same. So we have to first find out that area, after that we have to multiply with 2. Okay. Now see, here it is 1, okay, and here it is 3. So distance is 3 minus 1, that is 2, and here this line is actually 1. So 2 minus, here that line is 0 and that line is 1. So that line, that portion is also 1 length. Okay, that portion is 1 to 2, it is 2, and that portion is 1. So now the area is half into base into height, that is base into height. So that is coming 1. So that area is 1 unit, and similarly that area is 1 unit. So it is 1 unit plus 1 unit, so total 2 unit. Total 2 unit. So that thing also can solve by this technique. Okay. So far we have whatever discussed that. So here we have write down. For the first we have to find out the intersection points. After that we have to do it. So integration is so for what we discussed. Integration is actually a very powerful tool. Okay. So we are not only to try to find out. So far we are discussing only that area and area under the curve, together with the plenty of applications of these integrations in physics, chemistry. Like if you want to find out the work done by a force, you are pushing some force, you are giving some force, and you want to find out the work done, that thing also can be computed by this integration. Okay. Now if you are doing some decay, like those are doing problem, then in chemistry also some decay problem can be solved by integrations also. Okay. So there are lots of applications of this integration. Okay, and this method can be solved to find the volume and solid revolution. Okay, that thing also done. Okay, so that is the entire thing of the today's class. Okay.
Thank you, Pallab Maiti sir. It was a wonderful session. +2 மாணவர்களுக்கு இது ஒரு சிறப்பான வகுப்பாக அமையும் என்று நம்புகிறேன். +2 ஸ்டூடெண்ட்ஸ் உங்களுக்கு ஹையர் எஜுகேஷன் ரிலேட்டடாக ஏதாவது டவுட்ஸ் இருந்துச்சுன்னா நம்மளோட டோல் ஃப்ரீ நம்பரை 7029-200-200 என்ற எண்ணுக்கு கால் பண்ணிங்கன்னா நம்ம எக்ஸ்பர்ட்ஸ் உங்களோட டவுட்ஸ் எல்லாம் கிளாரிஃபை பண்ணுவாங்க. +2 எழுதவிருக்கும் மாணவர்கள் சிறப்பாக தேர்வை எழுதி நல்ல எதிர்காலம் அமைய வேண்டும் என்று ஜாய் பல்கலைக்கழகத்தின் சார்பாக வாழ்த்துக்களை தெரிவித்துக் கொள்கிறேன். நன்றி, வணக்கம்.